Today's lesson is 10.4, circumference and arc length. So circumference, this is the definition, is going to be the distance around a circle. So it's essentially the perimeter, which is the distance around a figure, but just for a circle. So over here we have two circles, and they're what we call concentric circles because they have the same center point. And I'm going to draw in here, and I'm going to ask you to do the same on your notes. A line just going straight up with point A and point C. I'm going to draw another one just kind of about here. It doesn't have to be absolutely perfect, with points B and D. I'm going to call this central angle right here 40 degrees. Now over here we have this question that we can answer. What is the measure of arc AB? Well, the measure of arc AB is going to be the same as the central angle. So it makes the measure of arc AB 40 degrees. Well, what about the measure of the arc CD? We can see this arc is a bigger size because the circle is bigger. But because it's still just a central angle, it's the same measure. So it has 40 degrees. So even though this arc is longer than arc AB, it still has the same measure in degrees because it takes up that much of its own circle. So this comes in, here we have an important distinction rather, where we have arc length is not the same as arc measure. So the length of it is not the same as how much of the circle it takes up. So arc length is a fraction of the circumference. We want to say how much of the distance around the circle does this arc take up. So the circumference of a circle is 2 pi r, 2 times pi times r. Or you might also see it as pi times diameter, since the diameter is 2 times the radius anyway. So in order to get the fraction part of this, you have to take the angle measure, the arc measure, I said angle measure, the arc measure, and divide by 360 degrees. Well, the reason you're dividing by 360 degrees, you might have guessed it already, is that's the amount of the full circle. So this first part's telling us how much of the circle is it, and this is saying, well, this is the circumference of the whole circle. And we're going to multiply these numbers together, because if we say, hey, how much of the circle is it, times the whole thing, we'll get the part we want in length. So our arc length corollary, kind of like a formula for us, is going to be that arc length is going to be equal to the arc measure, we just kind of wrote out, but a little more formal, divided by 360, the whole circle, times the circumference, which I'm going to give a capital C. And once again, the circumference is equal to 2 pi r. If that's something you might struggle with, go ahead and write it off to the side. Circumference is 2 pi r. So now we're going to go on to example 1 and find the length of arc AB. Well, first we need an arc AB. So I'm going to make a center. I'm going to have it go straight up and call it point A, and a little bit over and call it point B. And I'm going to say that this angle is 45 degrees, and the radius is 9 inches. We now have enough information to find the length of the arc AB. So what we say is the arc length, or as I'm going to call it AL, is equal to the arc measure. Well, the arc measure is going to be 45 degrees since it's the same as the central angle, over 360 times 2 pi r. And the r right now is the 9 inches. So that's our setup. From here, we continue on and do the math. So it's equal to 1 over 8 is what 45 over 360 simplifies to, times 18 pi is what 2 times 9 would be, it's 18 pi. And if we simplify those two together, multiply 1/8 and 18, we end up with 18 pi over 8. But that reduces to 9 pi over 4. And this would be in inches. Now let's say you don't want your answer in pi. Let's say we want it to the nearest hundredth. You could also write it as 7.07 inches. And that would just be using the pi function on the calculator. So you type 9 pi divided by 4 into your scientific calculator, and it'll give you 7.07 inches to the nearest hundredth. Let's go and practice on the major arc CED. So once again, we'll have a center, and I'll go up here and have point C, over here and have point D, and say that this is a right angle, and the radius is 15 inches. So the major arc CED, well, we need a point E, and it'll be right here. So this will be the arc length, once again, is equal to how much of the circle it takes up. Well, if this part is 90 degrees, the major arc CED is going to be the remainder of the circle, which will be 270 there, over the 360 for the whole circle, times the circumference, which is 2 pi r, or in this case, 2 pi times 15. So as we reduce 270 over 360, it becomes 3 over 4. And 2 times 15 is 30, so we have 30 pi. Well, as we multiply together, we can actually reduce and multiply in the same step if you want, and get 45 over 2 pi. If you're struggling with that, just take the 3 times the 30 and get 90, and then reduce the 90 and the 4. And this would be our answer in inches. That would be our exact answer. Now an approximate answer would be rounded to the hundredth, 70.69 inches. Two more problems on today's notes. We're going to have example 3 up here, finding the length of arc AB. Once again, you need to have a circle or center in the circle. I'm going to have point B up here and say that this radius is 15.28 feet, very specific. And over here, point A, and we're going to say that this angle, central angle, is 150 degrees. We now have enough information to find the length of this arc. Arc length is going to be equal to the arc measure, which is the same as the central angle, 150 over 360, the whole circle. Then take that times the circumference, the whole distance around the circle. And we're going to get 2 times pi times 15.28, which is the radius. So 150 over 360 simplifies to 5 over 12. 30 goes into both. And 2 times 15.28 is going to be 30.56 pi. As we multiply those together, the best this decimal simplifies to, without really getting very messy, is 152.8 pi over 12. That's just taking the 5 times the 30.56, excuse me. And so that would be the exact answer in feet. If you want the approximate, round to the nearest whole number rather, it would be 40 feet. Let's move on to example 4, a word problem. Here we're told the diameter of a bicycle tire is 30 inches. We want to know to the nearest foot, how far does the tire travel when it makes 100 revolutions? Well, one revolution would be the tire going around a full time. So if we have a tire, one revolution would be going a full turn. That would be the distance around the circle, aka the circumference. So reminder, circumference is equal to 2 pi r, or pi times the diameter, which might be more helpful here because we're told the diameter is 30 inches. So diameter is equal to 30 inches. So what we can do is we can find one revolution, aka one circumference, and take that answer times 100 of them. So one circumference is going to be 30 pi inches. So now if we take that answer times 100 revolutions, we end up getting 3,000 pi inches. Now we want to know to the nearest foot, so we got to estimate. So this would be approximately, in our calculator, 9,424.78 inches. And you might be wondering, well, Mr. Koss, why did you go to a decimal if we're going to have nearest foot? Well, I still like to carry a couple decimals in my problem before we start before we have our final answer, because we actually still have another step. We have to convert from inches to feet. Well, and to go from inches to feet, we have to say, okay, well, how many inches are in a foot? 12. So we take this number and divide by 12. And that gives us approximately, to the nearest foot now, 785 feet. So the answer to our question of to the nearest foot, how far does a tire travel when it makes 100 revolutions, is 785 feet. That is all for the notes today.